Just gonna start class now. I'm just looking on my I am, thank you. As well as I could be. Yeah. I'm good now. Oh, I'm good. I started work back. Yeah, it's just have to get used to this in Pakistan. I'm good now. Thank you, everybody. You guys can hear me all right, right? Am I loud? All right. Then no. Now I want to share my screen. Actually, no. How does that happen? That happens like this. And then that. Yeah. Alrighty then. Mm-hmm. 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 Let's share it there. Let's do that. Yeah. And yeah. Every time I have to set this. Okay, so let's do organic, right? That's what we're starting off today. That's what we decided to do today. You see the black screen, right? Mm-hmm. 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 And yeah, just turn this audio off. Yep. Okay, so okay, yes, everybody, let's begin. So what is organic chemistry? You know? Mm-hmm. Okay. So we're going to be starting with the idea of organic chemistry. And what is, like I was saying, organic chemistry? Now, what is, why do we study it separately? All that stuff is going to be, it's a whole different area of study in chemistry in university. It's a huge area. And why are we looking at it separately? Because it's the number of molecules that are part of this branch of chemistry are multiple thousands of times more than inorganic such substances. And every year they make about 300,000 or so new molecules, new compounds of our inorganic chemistry. Is not the case with the inorganic part of chemistry. It's a name from organic. The name comes because we first found these molecules in living things, but that doesn't have to be the case anymore. It's just that that's why the name stuck. It is the chemistry of carbon, really, outside of carbon dioxide and carbonates mainly. That's what it is. It is really, is the chemistry of, carbon. And it's not a big area in O levels. It is, but it's not too big. But in A levels, it becomes even more fun. There's a lot more to do in organic chemistry. Now, what do you have to, before we start organic chemistry, there are several things that you have to be reminded of about certain atoms, because the chapter that we will be really looking into first is bonding, because we are going to be using the idea of valency to really work out the molecules that we have. And at this stage, you should remember certain valencies, like the valency of carbon, So the valencies that you have to keep in mind are, for carbon's valency is 4, hydrogen's valency is 1, and oxygen's is 2. In some organic compounds, you find nitrogen also, its valency is 3. What does that mean? Well, that means carbon can make either 4 single bonds or a double and 2 single bonds, bonding. This is basically bonding. And hydrogen only makes a single bond. Oxygen can make 2 single bonds or a double bond. And nitrogen, generally for you guys, let's just leave it to making 3 single bonds for now. But that's what I mean by valencies, the number of bonds they can make. Well, obviously carbon can also make a triple bond, and that's also possible. A triple and a single. So carbon can make a triple and a single, a double and two singles, or four singles. Because what each of these sticks is a bond or one electron of carbon shared with something else. And each here, this is the basis of bonding you need to know to really work with carbon chemistry or organic chemistry. So reminder that these come from the number of outermost electrons, right? And second, the number of bonds, so they come from the number of outermost electrons. Carbon has 4, so it can share 4. Oxygen has 1, it can share 1. Hydrogen, oxygen has 6, but it only needs to share 2 to become 8. Nitrogen has 5, it only needs to share 3 to become 8. Now, you will not be seeing this fellow and this fellow in O levels, but you should appreciate that bonding can happen this way. The chemistry we'll focus on will not require these guys. But here, you should be aware of that carbon can make a triple bond, because that comes from its basic idea in bonding, and I have not invoked organic chemistry yet. Any questions so far? There are some. I can look at the Q&A also. No, there's nothing there. There's something in the chat. Chat me if you ask questions, then please use panelists and attendees so I can answer. I'm doing better now, Adisha. Thank you so much for asking. We don't study the triple bond reactions, Saad, but we should be knowing that they exist. They can exist, they do exist. All right? That much you should be aware of. Okay? Yeah? Mm-hmm. Mm-hmm, mm-hmm. Mm-hmm, mm-hmm. Mm-hmm, mm-hmm. Mm-hmm, mm-hmm. All right. So, now, do remember, do notice that carbon cannot make a tetra bond. It's not possible. It is not possible because of something called orbitals that you will study in A levels. So it's physically not possible for one carbon to make a tetra bond with another carbon atom. It is not possible. It's only going to make either 4 single, a double and 2 single, or a triple and a single. And that's what all it can do. All right? Okay, hi guys on Facebook, on YouTube, sorry. Let's not start a fight here if there isn't. I'm good, thank you. Thank you for nice name you have there, by the way. I should forget that I keep forgetting to disable this stuff. All right, so now, so in addition to that idea that you need to know this stuff, there's one other property that helps us understand why we have so many organic compounds. And you've kind of seen that already when you discussed and did the ideas of diamond and graphite, where you saw macromolecular structures of carbon bonding with each other. And what you realize and what you will need to know is that carbon has the ability to bond a lot with itself. Like you could easily make something like this, easily. And this idea that carbon can bond with itself in a longer structure, this idea is called catenation. Catenation, which is the fact that carbon can make multiple bonds with itself. Most other atoms cannot. You know, you're not going to find this list of O or N. It'll happen with carbon. Somehow the energies required to do this are just enough favorable to do it for carbon and nobody else. And so that's why organic chemistry is mainly based on the backbone of carbon and nothing else. If it was other things to do it, we'd have other areas of concern too, but we only really have uh, of carbon. Now these guys are allotropes of carbon, graphite and diamond. And what I've drawn here is neither an allotrope of carbon or graphite. I just made something here that these atoms could be anything. But carbon can bond with each other and still be able to make bonds with other things. In organic chemistry, we'll see this existing like this, you know. And so 1, 2, 3, 4, 5, 6, 7. This is heptane, an organic molecule. Is generally found as an impurity in petrol engines, in gasoline or petrol, because this is what causes knocking also in some distance. Now, when in organic chemistry, you're going to come across a lot of these compounds that are made of carbon and hydrogen only. And so organic chemistry will deal with a few things. First, the ability of carbon to make long chains with itself. That's called catenation. And in many of these molecules, it only bonds to hydrogen. And they become molecules of carbon and hydrogen only. And such molecules that are molecules of carbon and hydrogen only are called hydrocarbons. You guys deal with hydrocarbons on a daily basis. Okay? Even though this might seem very long to you, as a whole, this, for example, is a simple molecular structure. And its name, even though the naming we'll do later, its name is heptane. This isn't a macromolecule. This isn't a never-ending structure. Even though it looks long, it's still a finite structure. It's a few atoms still. It's not in the millions of atoms. So when there's only a few atoms in a molecule, it's called a simple molecular structure. So this is a hydrocarbon molecule where carbon has shown its catenation. Why is it hydrocarbon? Because only carbon and hydrogen exist. I'm not to say that only carbon and hydrogen are the only things that make, what you call it, organic compounds. Oxygen also can come in here, but we'll talk about that. I'm just giving you a basic intro right now. All right? Any questions so far? Hmm? Hmm? Now, okay, just give me a minute, guys. All right, sorry. Yeah. Just give me a minute, please. Okay. Where was I? Sorry, my bad. Let me show you some molecules also. What was I doing? Crap. Yeah, I actually have some molecules I'm transferring over to my iPad to show you. So you gotta just give me a minute and then I'll go on with this. I just realized I don't have it on my iPad. So I'm looking at my laptop and transferring it to my iPad. Give me just a minute of patience. Sorry. Mm. 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 What I need is not here. Hmm. Hmm. 1 second. Just sorry, patience. I'm so sorry. Just patience चाहिए मुझे 1 मिनट के लिए और. Mm-hmm. All right. Okay. So where was I? Mm. Sorry, guys. Yeah. Yeah, I'm bad. I'm sorry, guys. Just give me 1 minute more. All right. I'm just connecting back. I'm just. Yeah, just give me a minute, please. All right, guys. Uh, what was I saying? All right, guys. What was I saying? I'm back. All right. Can you hear me now, all of you? So yeah, as I was saying, so carbon has this distinct property, and I will take you through carbon. Now, it's all about carbon. Organic chemistry is all about carbon. Now, understanding carbon makes everything else easy to understand about the organic chemistry portion of things. Now, this is what the carbon atom looks like. It's these four that end up being bonded to hydrogen or oxygen or nitrogen. Yeah, and the idea is that this is how we end up making a lot of organic compounds. Now, what is organic chemistry? It's really, I mean, if we don't worry about defining it, think of it as everything to do with carbon except for carbon dioxide and carbonates. So if you can think about any compounds, any covalent compounds carbon makes with hydrogen, oxygen, and nitrogen, let's call that organic chemistry. And the most simplest version of this that you see on a daily basis, or at least I'm hoping most of you have interacted with this product on a daily basis, is the natural gas that comes in the gas stove ovens. And that has this dot and cross diagram. You probably have drawn this already. You did it with me if you've done this already. For the molecule CH4. This is the most basic, simplest organic molecule, methane, CH4. And in organic chemistry, we don't tend to want to draw dot and cross diagrams. They're just so inefficient. So a good way to represent this fellow, by the way, is going to be to use what we call a stick diagram or a displayed formula diagram. Okay, and this displayed formula is something like this. I'll zoom out a bit. So here is an easier way to writing the CH4. The CH4 is methane, and you can show these sticks are used to show the covalent bonds. All right, and for those of you who use obviously electric ovens, you don't see this anymore, but till a few years ago this was the gas that comes out. So the reason why I introduced you to stick diagrams earlier was because of the fact that it'll be easier to draw this kind of stuff. All right, now this is the easiest or the simplest organic molecule where carbon makes 4 single bonds, but that isn't the only place. I mean, I want to show you another place where carbon makes carbon-carbon double bonds, and that happens in another compound. This is CH4, that compound is C2H4, and let me show that to you also. And that fellow looks a lot like this right here. This is C2H4. In this particular case, the carbons are making a double bond, which means each carbon is sharing 2 electrons with each other. Because carbon has 4 outermost electrons, 2 of these shared here and 1 each shared with hydrogen, and this becomes another, and we've seen this in bonding also. This is called C2H4. It has a name. Its name is ethene, but I'll give you how to name them later. But this is another hydrocarbon because it's a compound of carbon and hydrogen. It's a simple molecule because there are only 2 carbon atoms and a total of 6 molecules, 6 atoms in this molecule. But the difference between this fellow and the previous one we saw was that this one has carbon-carbon double bonds, while the previous one had all single bonds, and this one has carbon-carbon double bonds. So I am just introducing it to you guys right now. Though obviously you'll have a systematic way of making this stuff. All right. Now this is the simplest extreme, and like we talked about earlier, carbon has the beauty and ability to increase this chain length by adding more and more and more carbons. And the way to start understanding organic chemistry is to think of it like Lego, by adding atoms, by atoms, by atoms, by atoms, by atoms. That's what I want you to think about. All right, and we'll treat carbon like Lego blocks, and we keep connecting it with something else, with something else, with something else. All right. So yeah, any questions so far before I move on with this? Anybody? All good so far? All right. So, yeah, awesome. So, what was I saying? Yeah. Let me show you one thing, 1 second. Let me go back to methane for a second to show you something else. So, in many times, you might have somewhere or the other, if you're lucky enough, maybe you watched The Big Bang Theory or you've seen some other geeky scientific documentary, and you might have seen something like this being used to represent organic molecules. These what we call ball and stick diagrams. I don't know if you've ever seen that, but that is a cool way to show the layout of atoms in a molecule. Here what I'm showing you on the right is a three-dimensional layout of an organic molecule. Now you won't be drawing this in O levels, but I would be unfair to organic chemistry to show its sexy cute side. And I find these little balls of fun to be quite exciting to look at. So this is also methane. It's CH4, where the white or this cream colored is a carbon atom, and these four balls in black are actually hydrogen atoms. Four distinct hydrogen atoms. And there's a reason why they're drawn at certain angles, because in the real world the angles between the bonds is not 90, you know. Yeah. Now on the other hand, these angles are not 90, but they're about, you know, if you ever heard the word tetrahedral for diamond, this is tetrahedral here also. Yeah. And so these fellows have that, and this is one layout. So understand that when we talk about carbon making four bonds, we have something like that. And so I want to show you a diagram where I can show you the catenation of using carbon like this. So if you think about carbon as just a ball with sticks sticking out, and then all you do is just connect the sticks together, back and front, back and front, back and front. That's literally how you make large organic molecules. All right? Okay, any questions so far? Where did they go? Okay. Yeah, no? There's somebody saying there's a lag? Okay, no, there's no lag. Yeah.
Yeah.
Oh, where?
Same.
So you see it's not together. So it's easier to see everything together. Can't I? Yeah, guys, just 1 second. I'm just transferring the other thing right now. The other file. It's almost done. Yeah, yeah. Yeah. Hmm?
The intro to, yeah.
Okay, I'm back. Sorry. So eventually you should be able to make some things like this. So the same ball and stick diagram, if I show you for a larger molecule and then show you a bit of those molecules, let me bring them down to you. So here, these might look like caterpillars, but they aren't caterpillars. They are literally four individual molecules. Do you see them? Four individual molecules. The blue circles are carbon atoms. The purple circles are hydrogen atoms. And there are some navy blue lines, but we'll talk about those lines later. Those are what we have intermolecular forces, also known as van der Waals forces. And these are carbon atoms, and so this is a 4-carbon molecule, which the one I'm highlighting right now. And there are 4 of these drawn on this page. So the idea is that this is a way of representing a molecule known as butane, which is C4H10. And you'll get to learn that also, okay? And it's not like you won't, you'll get to. And so the idea of what I was saying to you was that if you treat carbon like a unit of growth or Lego, and I'll show you something like Lego or other blocks, substances that maybe, expand and grow, then it might, if you can consider this to be that basic carbon unit that has 4 sticks sticking out, and here each carbon makes 4 bonds. In the previous case, each carbon was making 4 bonds. If you notice this carbon, it's actually making 4 bonds. Some of them are with other carbon atoms, some of them are with hydrogens. Like here, the end carbon, the carbon at the end, seems to be making 3 bonds with hydrogens and 1 bond with another carbon atom. And the reason why they can do that is because of this, that you can start treating a carbon atom like a ball with 4 spokes sticking out. And then each spoke can take another ball that can take 3 other spokes, because there are 4 holes in here. And literally, you can connect 2 with 2, and then you'll get something like this. Let me show that to you. So if you add 2 of these together, these 2 ball-like figures, and then from 1 you can become 2 like this. Let me scroll down like this. So you take 2 of these and you connect them, you can get something like this, where each ball has got 4 sticks coming out. The ball is carbon, the sticks can bond to anything else, but they can bond to another carbon atom also. This is the idea of catenation, and you can have it with 1, even 7, 8 carbon atoms. And so I wanted you to see these diagrams because it helps you visualize organic chemistry more, or at least better. I like it. I see them like that. And so here's an example of 1 bonding with another one to make 2, and then 1, 2, 3, 4, 5, 6, 7, 8 of these carbons sticking to each other, and each having 4 spokes, which is 4 bonds. Some in the middle. Out of the 4 spokes, 2 are bonded to other carbon atoms. And in most cases, the remainder bonds are taken up by hydrogen. It's not only the case. They could have been taken up by oxygen and hydrogen also, or other atoms that can make single bonds. But most cases you can have something like this. The idea is treat each carbon like a part of a unit, and you can keep on building on the unit. And you can have, instead of putting an H here, you could have put another ball here and make it a 9 carbon unit, a 10 carbon unit, 11 carbon unit. All that's possible. Yeah. And so the possibilities in organic chemistry are limitless, endless. All right. So now I'm going to move on to the most basic, organic chemistry groups of atoms. Now we've seen so far the fact that carbon can make 4 single bonds. What I showed you here earlier, which was this. These are 4 different molecules of butane. It isn't a polymer, they're just 4 individual molecules of butane. But now let's talk about some terminology and then some functional groups of organic chemistry. Am I making sense so far, guys? Yeah, No, that's okay. Perfectly. Great. Okay. Now, so what have we seen so far? What have we talked about? What have we seen so far? I'm going to put some English here. So what we've seen so far is carbon can make so many different compounds because a carbon atom can bond with other carbon atoms to make even rings. I showed you chains, but they can also make rings. A carbon atom can also form a single or a double bond to form other carbon atoms. Now, single or double I showed you. They can also make triple bonds, but we won't do that in O levels. They can also bond with hydrogen, oxygen, even chlorine, fluorine, bromine, because chlorine, fluorine, bromine, and iodine are group 17 atoms. And group 17 also has a valency of 1. That makes it very easy to bond to organic compounds. So that sticks I showed you, they don't have to only have hydrogen in them. They can also be chlorine, fluorine, and stuff like that also. So you can have chlorine, fluorine also on organic compounds. And so any compound that has the carbon hydrogen single bonds, we'll call that the study of organic chemistry, because carbon hydrogen bonds are the most common feature of organic compounds. I showed you already some, and now we'll talk about some more. All right, we're going to talk about the first class. We already seen that class. That class of compounds is called alkanes, if you remember. And what are alkanes? Remember? No, sorry, I told you hydrocarbons, not alkanes. Yeah, so let's talk about that. First is the first group of compounds that we're going to discuss are called hydrocarbons. What are carbons? What are hydrocarbons? Compounds of only hydrogen and carbon. And in this there are going to be two categories for us. One category we'll call alkanes and one category we'll call alkenes. And the difference for us would be that an alkyl, all carbon bonds, all of them are single. And an alkene, there'll be one carbon double bond. One carbon double bond. Meaning you're going to find two carbon atoms that are going to at least have a double bond. I showed you the example of ethene where there was a carbon double bond, right? You remember that? So you're going to have that also. That's another possibility. And then these are the two groups of hydrocarbons we'll see, after which we'll look at things like alcohols, things like carboxylic acids, and things like esters. So these are the functional groups that we'll see. Functional groups just refer to things that react. Now, because organic chemistry the things react a certain way. You're going to have alkanes have certain reactions, alkenes will have certain reactions. You're also going to come across another class of compounds that are alcohols, and they have a carbon that makes a bond with OH. You're going to have acids that we'll see later, but they are the weak acids we saw in acid-base chapter. And so we'll see these are called functional groups, because these groups of atoms make them behave different to others. So let me just scroll back up for a second. So alkanes, alkenes, and alcohols, acids. We look at them in more detail, but in alkanes, it's only a hydrocarbon. Alkenes, only hydrocarbon. These two are not hydrocarbon because they have an oxygen in them. All right. Now these could be other bonds, and we'll talk about them later, but they are not called hydrocarbons because they have an oxygen. When I said at least one carbon double bond, I meant that if there are other carbon atoms, they would be single bonds. Okay, that's what it means to be an alkene. I'll show them to you in more detail right now. But any questions so far of this? Any questions? Mm-hmm. None? Okay. Minimum one. Now alkenes can have actually multiple carbon-carbon double bond also. But you are going to deal with only those that have only one carbon-carbon double bond. But there are going to be more. I'm also going to introduce you to some terminology that we need to use. Just like hydrocarbon was one, there are other terminologies that will become tools for us to refer to things. And the reason why I want to do the terminology before I go into alkanes is because if you get the terminology right, then it becomes easier to communicate with you verbally. And I need that communication so that we basically, क्या कहते हैं, we become more efficient. And so I can understand alkene chemistry. So the reactions and all that come later. First, the basic English comes into play. You know, things like, you probably heard of some of the terminologies already. Functional, I just said functional group. Then I also mentioned, earlier molecular formula, empirical formula, earlier in moles calculations and stuff like that, right? And so you have that idea also. Then you also have displayed formula, structural formula. These are the ball and stick diagram that I showed you earlier. So all of these come into play into helping us to be able to communicate in terms of organic chemistry languages. Because काफ़ी होती हैं, there's a lot of conversations, and I don't want to be limited by explaining it to you every time, so I want to get some of the words right first. All right, you already know about the idea that there is a molecular formula and empirical formula. You've done that before, right? And then you also have things like I just showed for you structural formula, displayed formula, so all that stuff. So let me write it down for you also, okay? Sorry, I'm just a little too fast in speaking today. Mubaraka, the class is Monday, Tuesday, Thursday, Friday, Monday, Tuesday, Thursday, Friday, Saturday at 6 p.m. Pakistan time. Somebody asked on YouTube what the class was. How are you guys all holding up? Okay, at the Zoom class, all good? Fine. Generally, yeah. All good. Okay. Okay, where was I? All right. Yes, Arisha, we will be. Obviously, we will be. What kind of question is that? Oh my God. All right. So, a couple of terminologies I want to talk about. One of them is, we mentioned functional groups. Okay. And I'll mention this term again, functional group. Now, you should know what this means and you will not be asked to define it. Okay, you will just be क्या कहते हैं, I am going to use that term, because what's a functional group? It's an atom or group of atoms, okay, that determine the chemical properties, of a compound, determine chemical properties now of of a compound. Now I'll give you an example. In organic chemistry, anything that has this group of compounds, the OH group of compounds, is called are called alcohols. And so no matter how big or small the carbon chain is, they all behave similarly. All right, similarly. Saad, I am writing this on a screen where I'm just writing a video. I don't have these handwritten. I used to do that pehle. I'm not using that tool these days, so that's why. All right. Okay, Mubaraka, you can go on to the Teaching Circle website and sign up there for the free Zoom class code. All right. Teaching Circle, just search for it. Teaching Circle .1. So what that means is that there are compounds by name called methanol, ethanol, and these compounds have the same property. Why do they have the same property? Because they have the same functional group. Here's an example of methanol, and here's an example of ethanol. So obviously we'll be doing alcohols in more detail. I'm just talking about the idea of what a functional group is. And both of these have the same group of atoms common to each other that makes them an alcohol. And it's because of these two groups of atoms, they behave a certain way. So we call this functional group an alcohol functional group. For example, earlier I mentioned to you these guys, remember? So alkenes में the functional group is carbon-carbon double bond. Because of that, they behave a certain way. Acids में they have this COOH, which means they will all neutralize NaOH. So in organic chemistry, any compound that gets COOH like this will neutralize because it will have common reactions. So it will neutralize क्या कहते हैं alkalis. So that's what functional groups mean. All right. So that terminology was important to also to remember. Now using alkanes, I will explain terminologies like displayed structure, displayed formula, structural formula, and what was the word? Homologous series, all of that stuff. That's fun. A lot of fun stuff still coming along your way in organic chemistry. All right. But I'm sorry about the little delays in class today. Now, I'm going to wrap this up right now as an introduction to organic chemistry. We'll be doing alkanes and its reactions next time, and then alkenes, and then so on. All right? Is that okay? Saad, that's what I normally do too, but in O-levels, it's better to write them separately because in O-levels and IGCSE, they ask to show you all bonds. So right now, I am writing them separately, but over time, you can combine them also. All right. All right, guys. So I'm going to wrap this up right here, right now. Okay. Only because, I'm done with the portion of the chemistry that I wanted to talk to you guys about. All right. There's a little delay getting my bearings for this chapter, right? But I'm going to tell you for sure, this is going to be the most fun chapter we do. It's going to be so much fun and easy, and I'm hopefully make it exciting for you guys. All right. And tomorrow is Friday. Yeah. So I have a class during the time that Abul takes his class, so I can never take Fridays, but I'm hoping if I can take a Saturday class with you guys. All right. ठीक है? All right. And sorry about the classes issues earlier. All right. I'm gonna go now. Goodbye, guys. Have a good day. I'll see you guys Saturday. Hopefully, if I can make it. But yeah, but the class is definitely happening Friday, Saturday, 6 p.m. Alright? Chalo. Bye bye. Bye. Khuda Hafiz.